Yo, all right, welcome back. We are going to talk about limits of a different form. So, real quick, just to recap, what have we done? So, we learned that the first thing we always want to try when we do a limit question is to directly substitute. And if we get 0/0, we call that an indeterminate form. That basically means, all right, you got to try something. All right. So I'll just write try something. And the things to try were things like factoring, multiplying out, adding or subtracting fractions, maybe multiplying by a conjugate, maybe using an identity. And depending on the form of the expression you have, depends on what you would pick. That's not what this video is about. This video is about is what if you get number over 0? Now it's kind of poor for me to write that, but I'm going to write it. What I really mean is not 0/0. So in other words, something like, 5/0 or -3/0, where you get some value, some number other than 0/0. So what do we do in situations like that? This is not an indeterminate form. All right. This actually means that the limit doesn't exist. All right. But when we get number over 0, what I'm going to want you to do, and hopefully it'll make sense in a second, is we're going to use tiny. Like, what in God's name are you talking about? All right. So let's just do a question. So let's do the limit of 3 over x minus 2 as x goes to 2 from the right. All right. So following our normal rules, directly substitute. So when I directly substitute, I'm going to get 2 here for x. 2 minus 2 is 0. I get 3/0. So that tells me, oh, that's number over 0. Use tiny. What do I mean use tiny? Well, the bottom is really going to 0, right? So I'm going to 2 from the right. That means x minus 2, that expression is going to 0. But what side is it going to 0 from? So in other words, instead of writing 0, I'm going to replace that with the word tiny. But how is it getting to tiny? Like, what kind of tiny number is it? Is it a positive tiny number, or is it a negative tiny number? Well, it's pretty easy to figure out. Just pick a bunch of numbers to the right of 2 and chuck them in this expression and see what you get. So for example, number to the right of 2 would be 3. 3 minus 2, that's 1. Now, I don't care that it's 1. I care that it's positive. Well, keep getting closer to 2. 2.5, say. 2.5 minus 2, that's 0.5, right? That's positive. Get closer. 2.1. 2.1 minus 2, right? That's 0.1. That's closer to 0, but again, it's still positive. So you can see that I'm approaching 0 from the positive side. So what I'm going to do is I'm going to write 3 over positive tiny. Now, what does that mean? Well, 3 divided by a very small positive number is a very large positive number. So that tells me that this expression, as the bottom goes to 0, is actually going to go to positive infinity. Now, we're throwing around words like tiny, infinity, around here, and maybe that's not the most mathematical, but it's understood when you write this what it means. We know you can't actually, anything can't equal an infinity. But when we write that the limit equals infinity, we basically say that it's growing without bounds. So now, what does this mean? Well, this means the limit doesn't exist, right? But remember, this was a descriptive way of saying does not exist. So really, when you plug in and you get like 7/0 or -2/0, or in this case, 3/0, it's okay to say the limit doesn't exist, but it's on us to decide, well, can we further classify it? Can we further describe it? Maybe we can say it's going to one infinity as opposed to the other. And if we can, then we should do that. All right. So now let's take a look at what the graph of this thing looks like. So that should make a little bit more sense here. So let's get out of this. Let's go to our friendly Desmos graph. Bam, here we go. So this is the graph of 3 over x minus 2. And you can see it looks like I have an asymptote at x equals 2. And I do, in fact. I would make the function undefined. And this is what the graph looks like. If I want to zoom out a little bit, right? So now look at what's going on. As my x values go to 2 from the right, my functional values are doing what? They're going to positive infinity, They're not going to negative infinity. They're going to positive infinity. So yeah, the limit doesn't exist, but we're able to further describe it. All right. And that's basically what we want to do for these guys. All right. So now you have two different like limit forms. There's 0/0, which means I don't know what the limit is. So I got to try some sort of algebraic procedure to simplify it and then resubstitute. But now we have not 0/0, or I just like to say number over 0, understanding that the number can't be 0. When you have a situation like that, we're going to use Tiny to help us out. All right. So let's rock and roll. Let's do another one because there are a couple little snafus that we gotta address. All right. So here we go. So let's go ahead and do the limit of 2x over 3 minus x as x goes to 3 from the right. Okay, so directly substitute. 2 times 3, that's going to be 6. And at the bottom, you get 3 minus 3, which is 0, right? So that's number over 0. So that now tells your brain, let's use this concept of tiny. All right, so I really actually wouldn't even write 6/0. I probably would go straight to this. I'd write 6 over, and when I went to go 0, I'd be, woo, hang out. I don't want to write 0 in the denominator, so I know it's going to 0, so I can say it's a tiny number, but I have to decide, is it a positive tiny number or is it a negative tiny number? Now, you might be thinking, oh, you're going to 3 from the right. That looks like a plus sign. The other one you just did was a plus, so let me just put a plus there. But you can't really do that, right? You have to approach 3 from the right. So pick a number to the right of 3. Pick 4. That's to the right of 3. What's 3 minus 4? Oh, that's -1. Well, again, I have to keep getting closer and closer and closer to 3. So 3.5. 3 minus 3.5, that's going to be negative. 3 minus 3.1, that's going to be negative. And I can kind of see, I'm not going to flop signs here, that I'm approaching 0 from the negative side. All right. So the idea is you want to pick a number sufficiently close to 3 so you can decide what side you're coming from. When it's linear like this, 3 minus x, 3 plus x, 5 plus x, you just got to pick any number to the right of, and you're going to be all right. If it's not linear, then you're going to want to get sufficiently close. And you're like, what does sufficiently mean? Close enough to get the right answer. All right. So anyway, so how do we interpret this? What's 6 divided by a very small number? It's a very large number. But what's 6 divided by a very small negative number? Well, it's a very large negative number. All right. So we're going to get negative infinity there. So notice going from the right now, this time we got negative infinity. So that's why you just got to do like a little check. Just pick a number to the right of 3, sufficiently close to 3, plug it in and see what you get. All right, so now let's do this. Let's do the limit of 2x over 3 minus x. Yep, same problem, but now let's go to 3 from the left. So you're like, all right, again, directly substitute 6 over, and now maybe I'll do it this time. Whoop, I don't want to write 0. I know that's number over 0, so I say I'm going to write tiny. So now I have to determine, this is like the whole shebang. Is it positive tiny or is it negative tiny? Well, I'm going to 3 from the left. Give me a number to the left of 3. 2. 3 minus 2, positive. All right, keep going closer. 2.9999. 3 minus that would be positive. So I can see that as I get close to 3 from the left, I'm going to get close to 0 from the right, from the positive side. So 6 divided by a very small positive number, it's a very large positive number. So I'm going to get positive infinity. So now these are great questions, but what if I would have, from the get-go, said, hey, go ahead and do this, right? Give me the limit as x goes to 3 from both sides. Well, you should know what the answer is, right? Because you just did the limit from the right and the limit from the left, and you got opposite infinity. So I can't write plus or minus infinity here. So what I write is does not exist. Now, all 3 of these limits, the answer is does not exist. But for the one-sided ones, I was able to specifically state not only does it exist, but it's heading towards a specific infinity. I can't do that for this problem. So then you have to ask yourself, well, if you were to given me this problem first, then what would I have to have done? You would have had to have on your own look at these one-sided limits and see if these infinities matched up. Because if they matched up, then you'd write whatever it was here that matched up, plus infinity, or maybe they matched up both negative infinity. And if they don't match up, then you write does not exist. Now, in the back of your head, you might be saying, I don't know how they would ever match up. And that's all right if you're thinking that. Just kind of hold on to that thought. All right, so then let's just go to the graph to see if this makes sense. All right, so let's go ahead and go, whoop, do that. Back over here, take a look. This is the other graph. So when we turn that off, this is that graph. And there's an asymptoted 3. And kind of take a look at what's going on. As x goes to 3 from the right, functional values are going to negative infinity. As x goes to 3 from the left, the functional values are going to positive infinity. So what we just did, algebraically here is jiving with what we did graphically just now. All right, so let's keep going. Let's rock and roll. Let's go ahead and do another problem. All right, so let's do the limit of x plus 1 over x minus 6 as x goes to 6 from the right. And quite honestly, we'll do that. And then we'll do the limit of x plus 1 over x minus 6 as x goes to 6 from the left. And then we'll do the limit of x plus 1 over x minus 6 as x goes to 6 from both sides. All right, you should do these right now. You should pause the video, stop it right here, do these 3 problems, see what you get. All right, so now you're back. Here we go. Directly substitute, always what I try first. So I get 6 plus 1, that's 7. And then the bottom, I get 0 when I chuck 6 in. You're like, well, don't want to write that. So instead, I write tiny, right? Remember, when you plug in and you get number over 0, that is going to cue you to use this little system I'm calling tiny. So now you have to decide, is it positive tiny or is it negative tiny? Well, if I'm going to 6 from the right, pick a number to the right of 6, all right? 7. 7 minus 6 is positive, so good enough, all right? And really, I should keep getting closer and closer to 6, but again, I told you it was linear, so we're good to go. So now what's 7 over a very small positive number? It's a very large positive number. So 7 over positive tiny can be interpreted as positive infinity. Let's do this guy. Directly substitute. 7 over, don't want to write 0, I write tiny. Which way is it? Well, I'm going to 6 from the left, so pick a number to the left of 6. 5. 5 minus 6 is negative. That's going to be good enough. Technically, I should keep getting closer and closer and closer, like 5.9999, right? It's going to be negative. How do I interpret 7 over a very small negative number? It's a very large negative number. So now that I have the hard work done, the limit from the right and the limit from the left, then this answer, you know what the answer is. The limit is x goes to 6 from both sides. Done deal. It does not exist. Okay, let's go ahead and look at the graph of this. See if this guy makes any sense. All right, so come up Desmos, and there's the graph, and then do that. As I go to 6 from the right, functional value is going to positive infinity. So go to 6 from the left, functional value is going to negative infinity. So go to 6 from both sides, opposite infinities, does not exist. Now you might be thinking, how in the world would they ever be the same? So in other words, if you get a two-sided limit, can you always just say does not exist? All right, think about that. Maybe pause the video and see what you can come up with. All right, we'll give you a problem right now. All right, let's go limit of 1 over the absolute value of x plus 3 as x goes to negative 3. So right off the get-go, I'm doing the two-sided. I'm not holding your hand doing the one-sided. So you're like, well, wait a minute here. That's going to be 1 over the absolute value of 0. So where the 0 is, I put tiny, right? So then I have to determine if it's positive or negative tiny. So then I'm going to have to do the limit from the right and the left. But think about this, okay? Whether this was positive or negative tiny, what are you doing to that number? You're taking the absolute value of it. So whether it was positive or negative, you're always going to get 1 over positive tiny, which means you're actually going to get positive infinity here. So here is an example, right? Maybe I'll do the plus or minus there. Here is an example where, yeah, you can do a two-sided limit and both sides will end up going, in this case, towards the same infinity, right? And again, we can see this graphically if I just go ahead here and go to my good friend Desmos. All right, turn this graph off, put that graph on, bam, right? Here you go. As x goes to 3 from the right and as x goes to 3 from the left, your functional values are going to positive infinity, okay? All right, so those are your I like to call these tiny limits, all right? Limits using tiny. So the story here is, again, if you get, after you directly substitute, a number over 0, or specifically, really, not 0 over 0, then that means use tiny. And it more than likely means you're going to have to look at one-sided limits. So if you're a good student, you'd actually probably add that in there. All right, this is very different than 0 over 0, right? Which is an indeterminate form which means try and simplify, so simplify if you can. Maybe I'll say try and simplify. All right. And then, and resub. Okay. All right. Good stuff. See you soon.